Hello students, I welcome you all to the today's session. Let's look into the next numerical on concrete mix design. So the problem goes like this. Compute the concrete mix design for the following data using IS10262-2019. Grade of the concrete mentioned is M40 and type of cement given is OPC 43. Maximum size of the aggregate is 20 mm. Minimum cement content is given as 320 kg per meter cube and maximum water cement ratio is given as 0.45. Okay. Uh, Instead of these two data, they can just give you the exposure condition, that is whether the concrete is exposed to mild condition, moderate condition, severe. Okay, like this. If they just mention the condition of exposure, you can go to the table number 5 of IS 456-2000 and get these two values, that is minimum cement content and maximum water cement ratio according to the exposure condition of the concrete. Okay, so next data given is workability, that is 100 mm slump. Okay, so this workability can be given in terms of slump or in terms of compaction factor or in terms of VB time. Okay, so I have already given you the table in order how to convert the slump into compaction factor into slump, or VB time into slump. Okay, so instead of giving the workability in terms of all these three parameters, that is slump, VB time and compaction factor, they also can just give the method of placing. Okay, if they give the method of placing as pumping, okay, if they only give this data, then we have to take the workability as 100 mm slump. Okay, because for pumping of the concrete, slump required is 100 mm. Okay, so next, degree of supervision is good. Okay, we have left this data. Exposure condition is severe here and it is for RCC. This has to be mentioned whether it is for RCC or plain concrete. Okay, if it is not mentioned, you have to assume. Okay, then type of aggregate mentioned here is angular aggregate, important data. And then maximum cement content is 450 kg per meter cube. Chemical admixture is superplasticizer, and specific gravities of cement, coarse aggregate and fine aggregate has been given here. Okay, and also specific gravity of superplasticizer is mentioned here. Okay, then again, water absorption is water absorption by the coarse aggregate and fine aggregate is been given in the question, and they have mentioned that free moisture content on the aggregates such as coarse aggregate and fine aggregate is nil. Okay, so let's start with the procedure. Step 1 is to calculate the target. Okay, always remember for all the steps whatever data you're taking from the code book, that should be properly mentioned just like this. Okay, see, I have mentioned S is a standard deviation taken from table 2 of IS 10262-2019, which is 5 Newton per mm square. It is required to write this one always. Okay, whatever data you're taking from the code book has to be mentioned properly. Okay, so the target strength, first of all, target strength is a strength that is expected out of this concrete mix design. It is always greater than the uh, the grade of the concrete that has been given in the question. Okay, so to calculate target strength for mix design, f dash ck is equals to fck plus 1.65 into standard deviation, or f dash ck is equals to fck plus x, that is a constant. Okay, so two formulas have been given in code book, that is, you can check here. Here they have given both the formulas. Okay, and this yes has to be taken from this table 1, from this table from this table 2. Okay, our concrete is, grade of the concrete is M40, right? So the standard deviation S will be 5 Newton per mm square. Okay, similarly X should be taken from this table 1. Okay, for M40 concrete again X will be 6.5. Okay, so like this it has to be chosen. So after the calculation, f dash ck from the first formula comes out to be 48.25, and from the second formula it comes out to be 46.5. Okay, so we have to take or adopt the higher of the two. So I have taken 48.25 Newton per mm square. Okay, then everything should be mentioned properly, from where, from which table, from which code book you are taking the values. Okay, next step 2 is approximate air content. Okay, this approximate air content depends upon the size of the aggregate given in the question. Okay, so for 20 mm maximum size aggregate, from table number 3 of the IS10262-2019, approximate air content is 1%. Okay, so you can check here in the code book. Here, approximate air content given for 20 mm aggregate size is 1%. It is percent. Okay, so again coming back, so the step 3 is selection of water cement ratio. This is very important step. Okay, so from figure 1 of IS10262-2019, okay, so this is, it is not according to target strength, please strike it off. Okay, this is I have written it by mistakenly. Water cement ratio has to be chosen according to the curves. I'll just explain it here, how to choose the water cement ratio. Okay, this is the figure 1 from IS10262 2019. Okay, see here there are 3 curves given: curve 1, curve 2 and curve 3. Okay, so these, choosing of these curves depends upon the type of cement given. Okay, if it is OPC 33, then you have to choose curve 1. If the in question the cement given is OPC 43, then choose curve 2. Okay, if it is OPC 53, then choose curve 3. Okay, and again in y-axis is 28-day compressive strength of the concrete. Okay, this is nothing but the grade of the concrete that is given in the question. Okay, for us in the present question, the grade of the concrete given is M40. Okay, so this 28 days compressive strength, that is FCK, will be 40. Okay, so the OPC given in the question is 43. Okay, so I'll choose curve 2. Okay, so just check here, 40 and curve 2, just get it like this. Okay, then bring it down. Okay, so our water cement ratio is somewhere between 0.4 to 0.45, right? So I can take it as 0.42. Okay, so like this I have chosen the water cement ratio here. Okay, so the water cement ratio that I got from the graph is 0.42. Okay, so I'll adopt it as 0.4. You can just keep it as 0.42 as well. Okay, I have just taken it as 0.4. Okay, so the maximum water cement ratio that is mentioned in the question is 0.45. The one which is adopted by me is well within the limits, that is 0.4 less than 0.45, hence okay. Okay, so the next step is selection of water content. Okay, the water content has to be selected from table 4 of IS 10262-2019. Okay, for maximum size of aggregate, that is 20 mm. Okay, and all the contents of the table 4 are for 50 mm slump value. Okay, so let's look into this table 4. Okay, here according to the size of the aggregate we will choose the water content. Okay, the aggregate size given in the question is 20 mm, so the water content is 186 kg per meter cube. Okay, this is for the per metric cube of the concrete. Okay, so 186 kg per meter cube. This is for 50 mm slump value. All the entries in the table are for 50 mm slump value, but the slump given for us in the question is 100 mm slump. Okay, as you have already known, for every 25 mm increase in the slump we have to increase the water content by 3%. Okay, so the present slump is 100 mm, which means 2 times the 25 mm, right? So we have to increase the slump increase the water content by 2 times the 3%. Okay, so I have increased it here. Okay, so the total water content comes out to be 197.16. Okay, so next, here we are using superplasticizer. Okay, so by using the, what are the advantages of adding superplasticizers? They increase the workability. Okay, and then reduce the water content, right? So for using the superplasticizer we have to reduce the water content by 20 to 30% within this range. Okay, hence reducing, I'll adopt in between value, that is 25%, hence reducing the water content by 25%. Okay, after reducing 25% of the 197.16 from 197.16, I'll get the value of final water content as 147.87. Okay, this is about the water content. Next, calculation of cement or cementitious material. Okay, so the adopted water cement ratio is 0.40. Okay, we know the water content, then we can calculate the cement content. Okay, so the cement content that is calculated should be more than the minimum cement content that is given in the question, or if not given in the question we have to take it from IS 456-2000 table 5. Okay, so it is well within the limits, hence okay. Okay, so the next step is to calculate proportion of volume of coarse aggregate and fine aggregate. Okay, volume of coarse aggregate per unit volume of total aggregate from table number 5 of IS 10262-2019. Okay, so just check here, check the code book from table number 5. Okay, this is the table number 5. From this we will be calculating the volume of the coarse aggregate. Okay, in the question they will mention for which zone of the fine aggregate or sand. Okay, if it is not mentioned we have to assume. Okay, since in the given problem it is not mentioned for which zone the fine aggregate belongs, I have just assumed it to be zone 2 sand. Okay, so for maximum size of the aggregate 20 mm, I'll get the volume of the coarse aggregate as 0.62. Okay, so the values in this table are for water cement ratio of 0.5. Okay, so if any increase or decrease of water cement ratio, we have to increase or decrease the content or the value taken from the table by 0.01. Okay, so coming back to the numerical here. Okay, so for volume of the coarse aggregate from table comes out to be 0.62 for water cement ratio of 0.5. Okay, we have water cement ratio of 0.40 here. Okay, water cement ratio of 0.40 in the given problem we have adopted it. Okay, which is 2 times lesser than 2 times the 0.05, 2 into 0.05 times lesser than the actual water cement ratio, that is 0.5. Okay, uh, okay, so hence the volume of coarse aggregate has to be increased by 2 times the 0.01. Okay, just check here. Okay, so 0.62 plus 2 times the 0.01, final volume of coarse aggregate comes out to be 0.64. Okay, so for every where deflection, if the water cement ratio is deflecting or less than 0.5 by 0.05 times, then we have to increase the volume by 0.01 time. Okay, it is like that. Then the fine aggregate volume of the fine aggregate content will be equal to 1 minus volume of coarse aggregate per unit volume of total aggregate, because we have considered total aggregate content to be 1. Okay, so now we know the total aggregate is nothing but sum of coarse aggregate plus fine aggregate. Okay, so we know the volume of coarse aggregate as 0.61, 0.64. Deducting it from total volume of the aggregate, we will get the volume of fine aggregate. Okay, so that is 1 minus volume of coarse aggregate, we will get the volume of fine aggregate. Okay, next step is the concrete mix calculations. So always mix calculations are for 1 meter cube of the concrete. Okay, so the volume of entrapped air is 1% of the volume of the concrete, that is nothing but 0.01 meter cube. Okay, next volume of, here we will be calculating the volume of each ingredient, so that finally we can calculate the mass of the coarse aggregate and mass of the fine aggregate. Okay, so volume of the cement can be calculated by this formula, that is mass of the cement divided by specific gravity of the cement into 1 by 1000. Okay, so the mass of the cement given is calculated is 369. Specific gravity is given as 3.15 in the question. Okay, we will get it out after calculation 0.117 meter cube. Okay, again similarly volume of water can be calculated, then this is the value. Okay, again volume of superplasticizer. Okay, so the volume of to calculate the volume of superplasticizer, we want the mass of the superplasticizer or the quantity or the weight of the superplasticizer that is used in the mixed proportioning or mixed design. Okay, so if that is mentioned in the question, well and good, you have to take that quantity. If it is not mentioned, okay, you have to adopt certain value. Okay, so the value of a superplasticizer adopted should not be greater than the 2% of the mass of the cement. Okay, it should be within the 2% of the mass of the cement. Okay, so I have adopted here is 1% of the mass of the cement. Okay, mass of the superplasticizer or the content of the superplasticizer is 1% of the total weight of the cement. Okay, so taking that mass of the superplasticizer, I can calculate the volume of the superplasticizer in the concrete mix. Okay, finally after calculating the volume of all the ingredients of the concrete, I can finally calculate volume of all in aggregates. Okay, So according to this formula, deducting the volume of all the ingredients in 1 meter cube of the concrete, this is the final value that I get, that is volume of all in aggregates. Okay, so you already know concrete is a composition of all the ingredients such as aggregates, cement, water, superplasticizers, or you can say chemical admixtures and mineral admixtures. Okay, here from the total volume of the concrete I am deducting the volume of cement, water, superplasticizer, and yeah, that's it, superplasticizer. Then I'll be getting the value of the volume of the all in aggregates. Okay, so that I have got it here as 0.722. Okay, considering this volume of all in aggregate content, I can easily calculate the mass of the coarse aggregate. Okay, so by using this formula, mass of the coarse aggregate is nothing but volume of all in aggregate F into volume of coarse aggregate that we have calculated from table 5, then into specific gravity of coarse aggregate given into 1000. Okay, this formula is nothing but this formula itself. Okay, just by reversing or into I can say from that formula itself, this formula has been derived. Okay, then volume mass of the coarse aggregate can be calculated by substituting all the values. Okay, it comes out to be 111266 kg. Okay, in the same way volume of the fine aggregate can also be calculated. Okay, then next step is for the okay, step 8 is first trial of mixed proportions. Okay, without any site adjustments done here. Okay, so the cement quantity is 370, water is 148, then coarse aggregate and fine aggregate contents are 1266 and 712, then the adopted water cement ratio is 0.4. Okay, remember the quantity of the aggregates, that is coarse aggregate and fine aggregate, are of SSD. What is SSD? It is saturated surface dry aggregates, which means that aggregates are dry only on the surface but they have absorbed some moisture content. Okay, which is greater, the weight is greater than the dry aggregates. Okay, so the site adjustment, next will calculate for the site adjustments. Site adjustments. In the question it is given as water absorption of coarse aggregate is 0.5%, water absorption of fine aggregate is 1%. Okay, so what we will do here is we will calculate the weight of the dry aggregates. Okay, we will calculate the weight of the dry aggregates, then we will deduct the weight of the dry aggregates in the SSD aggregates, that is saturated surface dry aggregates. Okay, then we will get the water content that is being absorbed by the aggregates. Okay, that water content what is being absorbed by the aggregate is not available for the cement or for the workability purpose, right? So that we have to add extra to the water content that we have already calculated. Okay, because that will be absorbed by the aggregates when will not be available for the reaction in the concrete. Okay, so to avoid the scarcity of so much amount of water that is being absorbed by the aggregates should be added extra. Okay, that is what we are going to calculate here in the site adjustments. Okay, so we will calculate the mass of the dry coarse aggregate by using this formula. Okay, then we will also calculate mass of the dry fine aggregate by using this formula. Okay, we have got the masses of the dry aggregates. Okay, then finally we will deduct it here, deduct the dry mass from the saturated surface dry aggregates. Okay, for coarse aggregate and for fine aggregate. Okay, so this much is the water quantity that is being absorbed by the coarse aggregate. Okay, so this much is the water quantity that will be absorbed by the fine aggregate. Okay, so these two 6.3 kg plus 7.05 kg should be added extra in the concrete mix design. Okay, so the water quantity that is been calculated is 148. Okay, so then we will add this 6.3, then 7.05, then the total water quantity that has to be taken for concrete mix design will comes out to be 161 kg. Okay, so the final mix proportion is like this. Okay, here we will include the dry aggregates. Okay, then improved or adjusted water quantity, final mix proportioning. Okay, then this is the proportion of cement, fine aggregate and coarse aggregate proportion. Okay, so that's it. Thank you for listening.